Hi. So here's some notes on how you find the total force once you've drawn a force diagram. And the way you do that is what's called a vector addition diagram. The word vector, I'm sure I've described it before, but it's a fancy word that means arrow. So vector addition diagrams is arrow additions, how you add arrows together. You know how you add 1 plus 1 together. How do you add arrows together? This is what we're going to go through, these vector addition diagrams. So you're going to copy the notes for these. So there's a bunch of rules you need to get down, and I'll explain what they are as I'm doing them. So after drawing a force diagram, what you've already drawn, so you've got your force diagram here, you've gone through the rules for that, and you've F, G on blah, 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 F normal on blah, 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 blah. Beside it, you start a separate diagram. So you start over here somewhere. You redraw one of the forces, it doesn't matter which one, so let's start with this one. Then you redraw all the remaining forces, adding them to your diagram head to tail. So I've done the downwards force, now I've got to add the upwards force, I've got to add it head to tail. In a arrow, this bit's called the head of the arrow, this bit's called the tail of the arrow. If I'm adding head to tail, I'm bringing this one across here. I want to add the head of this arrow to the tail of this arrow. What that means is I draw this one over here, I draw it head beside the tail, right beside it, as close as you can get, go away. Head to tail like that. And the total force is what's left from start to finish. I started my first one here. I finished my last one in the same place. Okay, so in this case, there's nothing from start to finish. There's zero, which is what you'd expect for this situation. So I'm going to go through with some examples. So pause the video to copy those 5 instructions down on vector addition diagrams, and then once you've got that, you're going to copy down these 2 examples. So the cat on the mat. The force diagram was after we chose our system. It's not accelerating. These are the same size. We've got F normal, F gravity on cat by Earth, F normal on cat by mat. Hang on, I'm just got to let the dog out. Now, after drawing the force diagram, beside it, start a new diagram over here. Draw one of the forces. When you redraw them, you don't have to label them. So here it is here. That's the downwards force. You know what? I'm going to draw the other one first. Redraw the remaining force, adding them head to tail. So here's the head of this one, and I'm going to draw my downwards forces, the remaining force, right basically on top of it itself. The total force is what's left from start to finish. Well, they've started and finished at the same place. Total force is 0. When that seems pretty obvious, let's do a harder one. And I should say, copy that down. Copy that one down. You don't have to copy this down because you've already copied this bit down. Right, this is the other example you had was the baseball person sliding in and slowing down. And the force diagram that we ended up getting for that was look like this. I'm not going to label them as fully as you have it in your thing. I'm just going to label them really quickly. Okay, it doesn't matter, after drawing the first diagram, I've done that. It doesn't matter which, when you redraw one of the forces, which one you do for first. So I'm going to do this a couple of times and show you I get the same answer. Let's choose the normal force first. Okay, I've done it. Redraw the remaining forces, add them head to tail. So let's just go around in a circle. Let's draw this one next. Okay, here's the head of this, and I've got to draw the tail of the next one to it. So there's the head and the tail of the next arrow. Great. The next one is this one, head and tail of the next one. All 3 forces are in. Yeah. Total force is what's left from start to finish. Here's where I started from, here's where I finished from. If I go across to there, That's my total force. I draw my total force with 2 arrowheads. And in this case, that was terrible. The total force is that way, which is what I would expect from this force diagram, right? I would expect the total force to be that way, and that shows it to me. Let's do it in another order. Let's start with gravity first. Gravity. Then I'm going to go around and do friction next, head to tail. Then I'm going to do the normal last, head to tail. I started here, I finished here. Overall force that way. Hey, it's the same. I got the same answer as doing it the first way. Let's do it another way. Let's pick friction first. Friction. Then I'm going to do normal. Then I'm going to go head to tail, gravity. Go away. Goes back to here. I started from here. I finished here. Start to finish. Total force. Hey, it's the same thing as all 3 of them. It doesn't matter which one you redraw first, or which order you do them in. You always get the same answer. Here's a hint for when you go through and do questions. Other questions. The first ones you're going to do, I'm going to have it on the website, is just page 60, 61, and then on a separate day, I think I'm going to just check. No, I'm just going to get you to do the first. I'm just going to get you to do page 60, and then tomorrow you're going to look at 61 to 63. When you get things where they're on angles, make sure they go on angles. So this is a cat sitting on the roof. Remember, normal force is always 90 degrees to a surface. So in this case, here's a big hint. Gravity looks something like that, but the normal force comes up like this. There's a question which has a guy pulling a sled. And they say take the system as the sled and the kid on the sled. Okay, when you go to draw the tension force, the tension needs to be, I mean, there's going to be gravity down here, the tension needs to be up here. Oh, go away. Okay, you need to make sure you put things at angles when they need to be at angles. So the hint was, don't forget angles when you go to do these. Okay, good luck.